One of the biggest problems with this whole thing has been trying to figure out how to make sure that this is at least halfway visible in sunlight. This thing has to be battery powered, has to have a 4-hour-ish runtime. These are the modules that I chose to use. Just in terms of price and brightness, I've tried a couple others and they just weren't bright enough. These are about roughly half a watt a piece. So I initially tried, as you saw, 2 of them for about a watt, and those were adequate, but it just wasn't quite enough. So I went ahead and I made a housing with 4 of them, and I'm going to try that. The biggest issue with this is that it obviously doubles the power requirements. So I'm out of the ballpark of being able to power this via USB-C. So there's a total of 16, so it's 90 per sign. Now I'm making 2 of these, but that's not relevant. They're both not going to be powered on the same thing. One is essentially, as far as I know, going to be a backup. USB-C, even going to 3.1, which I would have to spin up my own board for that, because all the available boards from breakout boards from like Adafruit and SparkFun are USB-C 3.0. which gives you 100 watts. But even if I could go to USB 3.1, I think it's only 100, USB 3.1 is 180 watts. And my estimates are showing that this is going to be about 200 watts for the one scoreboard. So, and that's just the lights. That's not including the microcontroller and losses and efficiencies and things like that from conversions and stuff. So I'm going to have to go with a battery solution that is outside of USB-C. Probably have to add in a buck converter just to make sure that the voltage stays at the 12 for everything. Yeah, I had to obviously modify the housing, and then I had to modify the lens to make some cutouts so that it misses those LEDs, the LED housing, but so pretty much the same. So we're going to see what that does.